really have to be concerned about what we're building. And I want to point out, this is 1992. The standard template library does not yet exist. So we're talking about a serious concern about complexity before the STL existed. The language was much simpler than it is now. And so the standardization committee said, we've got to try to do something about this. And my favorite quote about this was from Jim Waldo, who was on the standardization committee at the time. And what he said was, we should have a rule that every proposal should be accompanied by a kidney, because that way no one would submit more than 2, and they'd only submit really important ones. And of course, the C++ programmer said, does it have to be your own kidney? Or could it be someone else's kidney? So still this huge stream of proposals. And so Bjarne was also very concerned about the language. And Bjarne said, listen, C++ is already too large and it's too complicated for what we prefer. And then he said, remember the Vasa. And everybody except the people from Sweden said, what's the Vasa? You have no idea no one can remember the Vasa. So the Vasa was a famous in Sweden sailing ship. It was commissioned in the 1600s. And originally, the idea was we need a warship. That's what we need. And they sent out blueprints and they hired people to build it and all that kind of good stuff. And then as it was being built, the king said, it'd be nice if we did this, so why don't you add that to it? And then they said, actually, instead of having 1 deck for cannon, let's have 2 decks for cannon. That would be a lot better. Oh, and can you take the ship and make it longer? That would be really, you don't say no to the king. So all these things happened. So ultimately, the ship was delivered. It was extremely heavily armed, looked really good in harbor, was very, very heavily decorated, had a little bit of a problem. So on its maiden voyage, it sailed a couple of kilometers, and a lot of people died. Ship collapsed, went into the harbor. It's actually in a very nice museum now in Sweden, because it was in really good condition and it didn't go very far. But it also didn't sail, which is not so good for a warship. You really would like your warships to go somewhere. So the analogy was, remember you built this sailing ship and it made it all decorated and very, very heavily armed, and everybody loved it on paper, and it collapsed and people died. And the idea was we don't want that to happen to C++. And if you take a look at C++, you sort of say, well, all right, is it heavily armed? That's kind of a lot of features. My favorites here are 2 kinds of enums. We've got 3 kinds of memory models, 3 kinds of references, 3 sets of rules for type deduction. By the way, this is wrong. There's not 3 sets of rules for type deduction. This is an area I've been looking into recently. There are 6 sets of rules for type deduction, and I am not kidding. So I think this is a heavily armed language. It's got a lot of ammunition. And in terms of, is it ornately decorated? So consider the really simple expression f of x. You're reading some source code, you see f of x. Invoke f on x. Really simple. What could that mean if you're reading it? Well, f could be a function, or a function pointer, or actually a function reference, because we have those in C++ too. Well, actually, f could also be an object of a class that overloads the function call operator. So it could be one of those. Actually, it could be an object that's implicitly convertible to one of those things. That would work too. It could be an overloaded function name. There could be a whole bunch of functions named f, and of course, they could be declared at multiple scopes. So it could be that too. It could also be the name of one or more templates, which could be also declared at multiple scopes. Actually, it could be the name of one or more template specializations as well. Actually, it could be all of these things simultaneously, pretty much. So we could have overloaded function names, we could have overloaded template names, we could have template specializations. I'm beginning to think I understand why people think this language is kind of complicated. I mean, this just doesn't seem as straightforward as we would like. This is a quote from someone else who was active in the community, very important, in 1990. 1990. That was 100 years ago, 1990. So Tom Gargle said, if you don't think C++ is too complicated, just what is a protected, abstract, virtual, pure, private destructor? And when was the last time you needed one? And it is very sad because when I read this, I went, well, okay, that means this. I mean, I knew immediately what he was talking about, which really is so sad. And I have never needed one. But that is legal C++. You can actually have that. Given that C++ has this enormous array of features and all these funny rules, and if you look at an expression like f of x, you can't say what it means. It's a little surprising that C++ has been as successful as it has. But it must have been doing something right. So there's a couple of ways we can try to measure how successful a programming language is. One of the things that people like to look at in recent years is the TIOB Programming Index, which is an attempt to measure how popular a language is. It looks at things like job listings and mentions on blogs and news groups and various kinds of discussion. One of the interesting things is that this is the last 10 years of data. So this is C++. Its popularity in 2002, it had about a 15-17% market share. Now you can see that it's gone down over time, and there's been a real drop recently, but I think that's kind of a blip, to be honest. But you'll notice that pretty much all the more popular languages like C and Java have also lost market share in that time. But if you look at a longer term perspective, C++ has been either the second or the third most popular programming language that has been measured in the last 25 years for all except the last year. It is only within the last 8 or 9 months that it went to position 4 when Objective-C overtook it. And whether that will continue to be the case remains to be seen. When you have a programming language that is one of the top 2, 3, or 4 programming languages for 25 years, it's got to be doing something right. There's got to be some reason why people are using it. Another thing we might look at is, well, all right, what percentage of projects that are open source are done in C++? And there's a company called Black Duck that measures this kind of stuff. They look at lots of open source projects and try to figure out what programming language they are primarily written in. And the most recent information, this is from last month, as I recall, C++ is in second place, second most popular language for open source.
ये the Anand show ये पूरा ऐसे ही है A capital S capital और T capital.
Trend line, so is this increasing or decreasing? It turns out that the change in the last year is actually up 2%. By comparison, C is down 14%. So it's increasing in popularity in open source, if you believe these data. So there's a lot of people using the language, which really does lead to the question, why are these people using the language? What is it about C++ that has made it successful for so long? So I want to talk about the reasons why I think it is successful, and I'm going to start with what I think is possibly the most important, which is compatibility with C. And I think people forget about the importance of compatibility with C. First, it's compatible with C programmers. It continues to be really easy to take a C programmer and say, listen, you already know a subset of the language. So all you need to do is start learning a few new things, not everything at once, maybe classes, maybe inheritance, maybe templates. There's an awful lot of programmers who program in C and they already know the basics of C++. That was important in 1982 when the language was first started. It continues to be important today because the longevity of C is truly amazing. In fact, if we go back and we look at the data that I showed you, so C's been the #1 or #2 language for decades. You'll notice that Java has now declined below C, so C was the #1 language for a while, then it was #2, and now it's back to #1. And these data go back to the 1980s. That's a really long time. If you look at the data for which languages are most frequently used in open source projects. In the last year, the percentage that use C went down by 15%, and it's still in the #1 position by a lot. So it was an important decision originally that C++ was compatible with C. It continues to be important. By the way, this is also one of the reasons why I think C++ is likely to be a language which will be important in the future. There's an enormous number of C programmers, and for every one of them, it is natural for them to consider moving into C++. So you've got a lot of people who basically already have an entree to the language. It was important 30 years ago, it's important now. Related to that is that C++ has source code that is as compatible with C as can be made. The phrase that they used was as close to C as possible, but no closer. But the fact remains, most C source code is also valid C++ source code. That has a lot of advantages. For example, you can take an existing C library and, if you need to, recompile it with a C++ compiler if you need to get a compatible binary. That was true 30 years ago, it's true now. It's not as trivial now as it used to be, but it's still an important feature. It is compatible with C object code. So it is really easy to go from C++ to C for some kind of very low-level manipulation that for some reason you can't do in C++. And one of the really nice things about C++ is you can link with C libraries. So people who have an investment in existing C code, C++ can naturally take advantage of that. That was important 30 years ago. It continues to be important today. When people are looking at programming languages, sometimes they think that, as long as the language is really good, that's all that matters. And programmers care a lot about language. But programmers care about other things too. They care a lot about their editors, for example. And originally, when you went with C++, you could say, listen, you can program using Emacs or VI, or if there's some other editor, you can use those too. But you could use build chains coming from C, you could use the linkers, you could use the debuggers from C. Sadly, I did program at a time when you had to use C debuggers in C++. It was not pleasant, but it worked.
What?
Which was not something you could say for all the competing languages.
Dungeon World? What?
The relationship between C and C++ is so strong even now that in a lot of places people talk about C/C++ like it's one language, which is kind of surprising because the C++ programmers look at C and go, that is not my language. And the C programmers go, that is not my language. But to the outside world, it's all kind of the same thing, and given the strong heritage and the strong linkage compatibility, they have a pretty close relationship. So I think the first thing that's important about C++ and continues to be important is the compatibility with C. I think another important thing that has led to C++'s success is a very general feature set. So rather than building in specific features to solve particular problems, they tended to solve more general problems. Interestingly, what everyone seems to agree on is that the single most important feature in C++, think for a moment in your head about what you would consider the single most important feature in C++. It has been there since the mid-1980s. What do you think? Pardon me? Closed curly brace. Okay, so what did you say? Template metaprogramming. Yes, that would be #1 on the list. So, destructors. Single most important feature in the language, probably. Destructors. Because destructors have led to the introduction of resource acquisition as initialization, which is a general purpose undo mechanism. This is a language with a general purpose undo mechanism. It can undo memory allocations. It can undo mutex acquisitions. It can undo opening files. It's a general purpose undo mechanism. It is the basis of general purpose resource management in C++. Other languages, for example, they have garbage collection, which is great. Garbage collection collects one resource, memory. On the rest of the resources, you're on your own. C++ has one mechanism, destructors, for doing deterministic finalization. It is the existence of destructors which made it possible to do resource acquisition as initialization, and that is what led to the ability to do the analysis to do exception safety requirements. As far as I know, mainstream exception handling analysis, determining what is the basic exception safety guarantee, what is the strong exception safety guarantee, that all came from the C++ community, and the foundation of that is destructors. Another general feature is templates. Now, other languages had some sort of generics, but templates were actually designed to be usable in ways that Bjarne had not anticipated, which certainly is what happened. So we started with generic programming like the standard template library. That led to template metaprogramming, and that led to some really interesting things that people were able to come up with. As an example, turns out that somewhere on planet Mars is a very nice little crater. And the crater was caused by a spacecraft crashing in there. It was called the Mars Climate Orbiter. The United States contributed a lot of money for it. I believe Europe did as well. And the reason we have a very expensive crater on the surface of Mars is because there were two pieces of software, and one of them was using metric units and one of them was using English units. Spacecraft go boom. Because it turns out that pounds and newtons are not the same thing. Through template metaprogramming, it has been demonstrated that it is possible to do dimensional analysis checking during compilation. The during compilation is what makes it interesting. You can actually check to make sure there are no dimensional type errors during compilation, which means it has absolutely no runtime cost. No one thought we would be able to do that when templates were first introduced. But templates are so general, it's something which was able to be done. This turns out to be more important than you might think. There are a lot of people in the world who work in symbolic realms. They're living in a realm where they say things like this. I can't read that formula, but there's physicists and mathematicians and statisticians, lots of people who live in a symbolic world. They're doing symbolic mathematics, and eventually they come up with formulas, and they say, this is a formula that could be important for our business. This is something we want to have implemented in a way that runs quickly. And usually that means it has to be translated into a programming language. So the programming language might be C++. So this happens to be the C++ source code, which I realize you can't read for this formula. This happens to come from a research paper from some people at one of the national laboratories in the United States, where they do some interesting work doing things like designing nuclear bombs. It is important that if you are designing nuclear bombs, that you design them correctly. The price of failure in every measure is very large. They test things really carefully, I promise. But what's interesting about it is that when you take a formula like this and you translate it into source code like that, you'd like to make sure you haven't introduced any silly type unit errors. By using template metaprogramming, there are people at these research labs have developed mechanisms for making sure that before they start running their simulations of nuclear bombs, and by the way, that was the first place I ever ran into people who talked about CPU months. They'd say, well, we'd run it for a few CPU months for an approximation of what we wanted to do. I thought that was pretty good, a CPU month. But you want to make sure you don't run it for a few CPU months and then find out you made a silly unit error. Template metaprogramming lets you avoid that problem. Not a common language feature. Overloading, another very general feature in C++. You can overload functions, you can overload operators. This is what gives rise to generic programming. It is what gave rise to smart pointers, which are an increasingly important role in C++. It gave us function objects, the overloaded function call operator, which most people think is odd the first time they hear about it. Well, the overloaded function call operator is actually the basis for lambdas, and lambdas are one of the most useful features in C++ 11 and C++ 14, but you couldn't write them if you didn't have the basis in the first place. Which means that C++ in contrast to other programming languages, is a language for library writers. It's not really a language designed to say, let's write applications. It was designed from the beginning to say, let's be able to write libraries. The thinking was, if we can write a good language for library development, library writers will create great libraries for application development. So it's a different way of thinking about what your programming language is used for. So I think that's an important reason for C++'s success. Another important component is paradigm agnosticism. At a time when some languages we're procedural, or we're functional, or at the time C++ was developed, we're object-oriented, C++ says, I'm all of those things. So if you want procedural programming, great. You want free functions, you've got free functions. And in the 1980s, this is at a time when everybody said everything must be an object. And C++ said, nah, functions are okay, which is the basis of the standard template library. The whole standard template library based on free functions, completely different idea. It also meant you could naturally model symmetric relationships. If you can't put things outside classes, then if you have a relationship between, well, I have a matrix class and I have a vector class and I want to be able to multiply matrices and vectors together, which class does that belong in? It actually goes to both of them. And in other languages, you have to choose one place or the other. And in C++, you say, no, you just put it outside both of them. It's going to work fine. It also means that after someone has defined a class and given the directive functions, if someone comes along and says, you know, that's a useful class, but I wish there were some additional functions that it had, that's no problem. Now, obviously, they can inherit from it to add if they want to, but they don't have to inherit. Instead, they can just say, I'm going to start writing some free functions which work on objects of those types and give me the functionality that I need. Which was sort of a radical idea, but what I find interesting is that other languages have adopted the same idea. For example, C# has something called extension methods, which are essentially the same thing. It's a way to add functionality without opening up the class. D has something similar. Turns out they offer a little more syntactic sugar, but the whole idea of you've got the class and then you've got other stuff related to it, that was in C++ before other languages picked up on it, and that has proven very successful. We've got object-oriented programming, obviously, including multiple inheritance, including 6 kinds of multiple inheritance, but nevertheless, including multiple inheritance. We've got generic programming. Now, the standard template library was authored by Alexander Stepanov. Alexander Stepanov is not a fan of C++. And he really hates inheritance. Basically, he doesn't like classes, he doesn't really care for objects, he thinks the whole thing is kind of nonsense. Yeah, this is the man who wrote the standard template library. But when you read his writings, what he tells you is he had a vision for how he could write code that would work with any type and would be as efficient as if he hand-tuned it for a particular type himself. That was his vision. And he said he tried to implement the standard template library in other languages. If you go and you search online, you'll find a number of places where he's exchanging debates basically with either people from Lisp or people from name your favorite language. He goes, look, I tried in all those languages. It just did not work. C++ was the only language in which I could get it done, which I think is a testimonial to the power of the template system. And it was not, the template system was not designed to do that. You got functional programming, so we've got closures, which it's not the best functional programming language in the world, but it's moving in that direction. But it also has template metaprogramming, which is a purely functional programming language. There is no assignment in template metaprogramming. Everything is a pure value. It's immutable once it's been created. It's a really ugly functional programming language. But nevertheless, it is a functional programming language. You want to run with scissors? You want to get hurt? That's no problem. If you want to do unsafe programming, C++ can do it. Pointers, casts, unchecked arrays. In the rationale for the C programming language, there's an official rationale for the standard for C, at least for C89. And one of the things it says is trust the programmer. We're not going to put on, any safety features necessarily. We're going to trust that professional software developers know what they're talking about. At the same time, if you want to have safe programming, you want vectors with bounds checking, you want to have checked iterators to make sure that things work okay, you can write those. It's a language for library developers. Certainly one of the most important reasons why C++ has been successful is a fundamental commitment to systems programming. I have said for many years that I believe C++ is a language best suited for what I call demanding systems applications. Demanding systems applications means that you've got a system you need to write and there's something about it that's particularly difficult. There's a constraint you have to satisfy. The constraint might be it has to be really fast. The constraint might be it has to use minimal power. The constraint might be I've got a data format that was designed by somebody programming in Fortran in the 1960s, and we've lost the source code, but we have to talk to it, and I'm not making that up. Anybody here ever worked at a company or heard of working at a company where they had object code and they'd lost the source code? Okay, there's a few people. There are companies who go, okay, you have to link with this object file, but we've lost the source code. C++ says if that's what we need to do, that's what we can do. So if program speed is important to you, and there are some application areas where you can just not run fast enough. Simulations, for example, you can't run fast enough. Doing computer generation of images for video games, for example, you cannot run fast enough. Number crunching applications, you typically can't run fast enough. There's more applications than people think where speed is really important. C++ has been very successful in those domains. Program size. Sometimes you really need to make sure that your footprint has been minimized, either because that's got to be your working set's got to be as small as possible, or it's got to fit into some really tiny embedded system. C++ tends to give you control over that kind of stuff. Data layout. Data layout can be really important. Maybe you've got a driver, it's got to talk to the hardware, and we've got, bit 3 and bit 19 do weird things. So I've got to talk to bit 3 and bit 19. Funny hardware where if you want to turn something on, you set the bit to 0. Weird stuff. Communications protocols, working with legacy systems. C++ says, no problem, you tell me what the format is, you tell me what the rules are, I can write the code to get that done. This is the kind of stuff systems people deal with all the time. You need to have a way to efficiently communicate with peripherals. You need to be able to communicate with external systems. Operating systems, you need to talk to other programming languages, like C, for example, or anything that talks C. C++ does all that stuff, and it's designed to do those things. One of the language's fundamental hallmarks is the idea of zero overhead. Often you hear, you don't pay for what you don't use, which is a runtime comment. You pay during compilation for everything. But at runtime, generally speaking, if you're not using a language feature, it costs you nothing. Something systems programmers really appreciate. Furthermore, C++ is designed from the beginning for very wide platform availability, microcontrollers to supercomputers. This is one of the reasons, by the way, we don't have a fixed, we don't say ints are at least 32 bits or exactly 32 bits or something like that. Because if you're programming a microchip like that, it may have an 8-bit compiler or only a 16-bit compiler. There are no assumptions about I/O capabilities. There aren't even any assumptions that you have an operating system. C++ does not require those kinds of support mechanisms. It's convenient to have, but it's not required. One of the results of that is you can find C++ compilers almost everywhere. Pretty much any kind of hardware you want to run on, someone's got a C++ compiler for it. Might be a really lousy C++ compiler, but it's still a pretty reasonable way to write C++ code. Other programming languages, if you're trying to do programming unusual digital signal processing chips, or unusual video game consoles, or some kind of special driver that's only found in certain kind of hardware, you may not have any choice. Especially in recent years, I think that it's emerged that one of the most important features in C++ is its dedication to backward compatibility. One of the reasons C++ is as complicated today as it is because we sort of said, listen, if you invested the time, or from a company's point of view, the money to build up an asset in C++ 20 years ago, we will keep that code running if we possibly can. Source code written in, let's say, 1989, these days, probably will still compile under C++ 14, and it will do the same thing, probably. There's a few places where it might change. But that's a fairly impressive record that we can go back 25 years, let's say, and say, yeah, the source code from 25 years ago, that still works. That still compiles. That's important for companies which have very large investments in source code bases. You don't want to have them gratuitously rewriting their source code all the time. May not be a sexy reason, but it's an important reason. If we take a look at C++ and compare it to the Vasa, we can say, well, okay, this is something even Bjarne said 4 years after standardization started. He says C++ has escaped the fate of the Vasa. It didn't keel over and disappear, and certainly people have been predicting C++ was going to die for the last 20 years. And I think the reasons why it hasn't died, why it continues to do a very good job and be a very important programming language, is because it's compatible with C, it's got a very general feature set, it doesn't take sides as regards the particular programming paradigm you have to use, and it has a commitment to systems programming and backward compatibility. I want to talk a little bit more about this complexity thing, because I hear people a lot complaining about complexity. So this is what we talked about earlier, that we have f of x, and it can be all these different things, which it certainly can. How complicated is this? I say, I want to print out x. Anybody have trouble comprehending what that does? The reason I'm asking is because the output operator is overloaded, it is templatized, and it is specialized in multiple scopes. It has all the problems I mentioned earlier. And yet, in practice, when you actually try to use it, I think most programmers can figure out what's going on here. Tracing the code might be kind of a pain, but it's not so complicated, which is interesting because it means that although there is this potentially large amount of complexity, in practice, it doesn't arise as often as you might think. If something's complicated, it can be complicated for a couple of different people. It can be complicated for users, or it can be complicated for implementers. So this is an example that the people who were in my class earlier today should be able to appreciate. So if I say something like, okay, I want to move x into y, pretty much everybody understands exactly what's going on with that. Maybe you need 15 seconds of explanation. It's not a complicated thing. That's the user view. That's the user view of move. Now, the implementer view of move is less pleasant. So this is how move can be implemented. And understanding exactly what's going on there takes a couple of hours of fairly intensive study. But that's the library implementer. For the person using the library, not as complicated. I think it's also worth noting that for the most part, if people decide to use C++, my experience is they've usually already ruled out a bunch of other languages. They've already decided, look, it really is a demanding systems application. We can't get it written in some other language. And if that's the case, it sort of means there's a certain degree of self-selection, which is that the people coming to the language, they've already got complicated problems. So if you've got a complicated problem, complicated problems often have complicated solutions. The world is a dirty, messy, complicated place. Somehow, that dirtiness, that complication, is going to be reflected in the software. And if you also have to run, let's say, as fast as possible, or compatible with some data format defined by somebody else, then C++ may be what you turn to. Which sort of implies that if you choose C++, you've already got complications. So that could be a reason why C++ seems more complicated than other languages. And then the people who use C++ are special. I spend a lot of time talking to people about C++. I spend a lot of time explaining things, and actually the last 3 days has been a really good example of this. I'll sort of say, okay, here's a new feature, so I'm talking about this new feature, and what I want to do is I want to talk about the sweet spot where the feature works completely normally, completely regular. Everything's exactly the way you would expect. And the people in the class go, yeah. What I want to know is what happens right here on the boundary of the design space. You know, what happens if this is true, and this is true, and this is true, and this is true? And they go, well, okay, what happens right here, you know? And then they'll go, well, okay, what happens if I try to do something which is impossible? What would happen if I did this impossible thing? So it is entirely possible that one of the reasons that C++ is complicated is because you're all sick. I'm just raising it as a possibility. There are some people who truly have a love affair with complexity. This is a good language for those people. So C++ is a language that is being changed. For 13 years it didn't. 1998 to 2011, it did not change very much. So in 1990, the ARM, the Annotated Reference Manual, first book on C++ that defined it, 453 pages for the whole language, and that included explanations. 453 pages. Well, so C++ 98, 776 pages, no explanations there. 776 pages, 71% bigger, took 8 years. C++ 11 took 13 years. 1,353 fun-filled pages of text. 75% bigger. But you can sort of see, you know, we wait 8 years, we get this giant document. We wait 13 years, we get this giant document. C++ 14, only 1% bigger, good news, only about 20 pages longer, but it only took 3 years. C++ 17, only another 3 years, probably going to be a lot bigger than C++ 14. That's my expectation. Bigger is more complicated. When you consider that in C++, we are largely committed to backward compatibility. What that means is, generally speaking, nothing's going to go out of the language. There's a few things that get removed or deprecated, but almost everything in the language today, it's going to stay there, because that saves people's investment in legacy code. Which means we keep adding new stuff to a language which is already really big. Which means it's going to get more complicated. It seems obvious. You start with something that's big and complicated, you make it bigger. And yet, I think we can say there is actually some simplification through added complexity. So if we think about how we would do something on every element of a vector in C++ 98, you'd write a loop that looks something like this. And you're typing stuff like, I've got to create iterators, and I've got to explicitly test and increment them. Standard C++ 98 code. It works. We've all written it. So in C++ 11, we can make it a lot easier. If we want to deal with iterators, we can just say auto and C begin, and suddenly it becomes a lot shorter. A lot shorter. But in many cases, we can just use a range-based for loop. Now, this code here that was legal in C++ 98, it's still legal. And these two things got added. So the whole language got bigger, but from a programmer's perspective, things got simpler, which I think is a nice improvement. If you think about function objects and how they got created, so in C++ 98, let's suppose I would like to create a function object which will tell me whether something is between, let's say, 10 and 20. Well, if I wanted to do that in C++ 98, I would write code that looks like this. That's a fair amount of code to have to say, I want to check to see if it's between 10 and 20. In C++ 11, I can write a lambda expression. It takes 2 lines. That seems like kind of a nice improvement. Now, this code continues to be legal. So the language got more complicated. We just don't write code like that anymore. So the old code keeps compiling, the new stuff is simpler. Let us suppose what I would like to do is write some kind of a function. This is C++ 11, and what I want to do is take some arguments, and I want to be able to perform an operation. In this case, I want to validate credentials.
Hello.
And then I want to forward those arguments to some other function. So this is how you would do it in C++ 11. This is how you could do it in C++ 14 with polymorphic variadic template lambdas. So C++ 14 makes all that turn into that. So yeah, the language is getting bigger. So technically, I mean, this is why the specification is going to probably break 1,500 pages. But that doesn't mean that it's necessarily going to get more complicated. It just means that the old stuff keeps working and the new stuff is going to start working as well. So if we think about the fate of the Vasa and compare it to the fate of C++, if you'd like to see the Vasa, as I said, it didn't sail very far. It was barely a used ship. And they got it up off the bottom of the harbor. They put it in a museum. You can go and admire it in, I think it's in Stockholm. And C++, on the other hand, is a language that is being used all the time. People are still working with it. It's getting important work done. And I think the reasons for its success are the ones that I have mentioned. So, any questions about my perspective on the success of C++? So the question is, what do I think about its future for, let's say, 10 or 15 years? Purely from a pragmatic perspective, there is such a large installed base of C++. This is going to be a really important industrial language for decades to come. That would be even if nobody continued programming in it, and a lot of people are continuing to programming in it. So I think that it is going to be at least as important on an industrial basis as it has been. It's probably never going to regain the cachet of being the sexy language that all the cool people are using. On the other hand, I think it's going to be used extensively in demanding systems applications. So for example, there's the well-known example of Facebook was writing everything in PHP. And they couldn't get enough servers and they couldn't get enough electricity to keep the systems running. They wrote a PHP to C++ translator and they improved performance by some very large percentage. I don't remember, 40%, 60%. What's interesting about that is a friend of mine who you may have heard of, Andrei Alexandrescu, has written some C++ books. And he works at Facebook, and one of the things that he does is he works on improving performance. And what he tells me is, if you're at Facebook and you can get a 1% performance improvement, it runs 1% faster for Facebook, that saves the company millions of dollars per year. So 1% equals millions of dollars. Now, there's not a lot of companies like Facebook, but there are a lot of companies, there's enough companies that have large server farms that are doing lots of computation where these small increments can make a big difference. So I think that in the realm of demanding systems applications, C++ will continue to be very popular. Yeah.
And I've heard that there is already some production code used in Facebook written in D. So my question is, what's your opinion on the D language comparing with C++?
Okay. I don't know D. So I can't really comment on that, which is sort of ironic because 2 weeks ago they asked me to give a keynote address at the D conference. It turns out, I was somewhat surprised to see this, it turns out if you go to a conference for a programming language that is different from C++ and you say uncomplimentary things about C++, you're a big hit. D is an interesting programming language. I've read a book about it, but I'm not a D programmer. What I will say is I talked to Andre about it because Andre is very interested in seeing the popularity of D increase. He'd like to see more and more companies use it. But one of the things that he told me is the hardest people to convince to use D are C++ programmers. Because if you go to the C++ programs and you sort of say, here's this new language, look at this feature, look at this feature, look at this feature, and the problems that it lets you solve, the C++ people go, well, I already know how to solve that. I know how to do that. Well, I can do that too. Which I find interesting because when I first started teaching people how to program in C++ a long time ago, I was always teaching C programmers. And when I would teach the C programmers, and I'd say, look, let's talk about some really cool stuff you can do in C++. For example, virtual functions. I'd say, isn't this great? You can have a pointer to a base class. We had pointers to base classes back then. You had a pointer to a base class, and you've got a bunch of derived classes. You can create a container of pointers to base class. You can call virtual functions, and it automatically calls the right function for the object that you're pointing to. How cool is that? And most C programmers were like, that's cool. But the really good C programmers would go, well, what's the problem? All you have to do is create a struct, put an array of function pointers inside it, initialize it, and where's the problem? So these days, from what I can tell, the deprogramming language is not sort of targeting C++ programmers. They're trying to establish a reputation on their own as being different from C++ as opposed to better than C++. And it will be interesting to see what happens to D. But you know, in theory, it's a competitor to C++, but I think that right now that's not really what they're pushing.
Thank you.
You mentioned that C++ standard has 104,000 pages, and how many pages do you estimate its good parts of C++ for nowadays?
How many pages what?
It's good parts. Good parts.
Oh, how much of it is the good parts?
Not a page number, just...
You know, I mean, most of it is good parts. Because the thing is, a bad part to me would be this is something that you should never use or that has no reasonable application. And there are a few things where I would say, okay, you should probably never use that, or it's been replaced by a better way of doing things. An example that I mentioned in my talk earlier today, for example, bind. Standard bind is a useful part of the library. A lot of people have used it. I believe that as of C++ 14, there is no reason to use bind. So I would say bind, really we could get rid of bind. Now we're never going to get rid of bind because there's a lot of legacy code that uses it. But that would be an example of something that I think probably we could do without. But everything in there probably does have an application, almost everything, at one time or another. So I would say most of the stuff in there is good stuff. I think it could probably be made better stuff in some cases. But I think most of what's there is probably reasonable.
Is there any slightest chance that C++ in foreseeable future will get rid of C preprocessor or make it unnecessary like bind?
In my opinion, no. There's a whole cottage industry of people who do preprocessor metaprogramming. One of the biggest impediments to writing tools for C++ is dealing with the preprocessor because it's very extensively used. I think that many people would like to get rid of it. Nobody likes it, but it lets you do stuff you can't do in any other way. So I think, realistically speaking, the chances of that going away in the foreseeable future, very small.
Do you heard about Herb Sutter C++ ABI proposal and what you think, how important it for C++ future?
Which proposal?
Herb Sutter proposed ABI for STD library in STD ABI namespace that allow different compilers use one library. ABI.
Oh, the ABI proposal?
ABI.
I know that Herb has been working on proposing an ABI. I think it's a very recent proposal. I haven't read it myself, and I have no idea what the chances of that being adopted are.
Okay.
Yes, it's Herb Sutter, and I still have no idea what the chances are of it being adopted. It's important not to put too much stock in personalities. As an example, if you call async, I'm going to assume you all know everything. So here we go. If you take async, you get a future from it, then the shared state referred to by the future from async causes your thread to block in its destructor. Most people agree this is a really bad idea. Herb hates it. Herb hates it so much, he convinced the Microsoft compiler team not to implement it. He was so sure that he'd be able to go to the standardization committee and say, listen, we've got to change this behavior. So he wrote up a proposal, he went to the standardization committee, and the result was they didn't change anything. And I believe the reason was they said, listen, Herb, we agree with your arguments in general. The problem is this has been published since C++ 2011 came out, and now there's legacy code that depends on it, and we do not want to break that legacy code. So Herb Sutter is a great guy. He gets a lot of stuff done. He has a lot of weight on the standardization committee, but that does not mean he gets his way. So he can come forth with an ABI, and that's great, and people might build on it, but there's a lot of vendors you have to get on board to do something as big as that. I'd love to see an ABI. It's a great shortcoming in C++ that we don't have one. But I think it's important to recognize that most standardization proposals are not adopted.
Hello? May I ask?
Thank you.
May I ask a personal question about your career, about your personal consultancy? In short words, what's fun about it? What's interesting, and how you became this path?
How I got to doing what I'm doing?
Yes.
Sure. Ask. In 1985, I got bored of working, so I went into a PhD program, which is a great way to make no money but not be bored. And when I was in the PhD program in 1988, I was asked to be a teaching assistant in a class on software engineering where the professor said we're going to use C++. That is when I had to learn C++. So I learned C++ in 1988, and then about a year later, someone came to me because there are various training companies in the world, and if you're a corporate training company, what you want to do is go to companies and say, we have great trainers who can teach you new technology. And then the companies go, ooh, we have money, take some from us. The problem for the training companies is that they need to find people who can go and teach for 1 week at a time, who don't want to be employees, who are experts in technology and good at teaching. This is what graduate students were made for. It's a perfect match for graduate students. So a professor came to me and said, Scott, how would you like to make more money in 3 days than you currently make in a month? And I said, I would like that. So that led to my teaching C++. And at the time, I would go for week-long hands-on courses to teach C++ to C programmers. And I think most people now can't imagine what this must have been like, because C++ was a very simple language compared to the way it is now. But think of yourself as a poor C programmer. You've never heard of classes, you've never heard of constructors, you've never heard of destructors, you've never heard of default parameters, you've never heard of overloading, you've never heard of inheritance, you've never heard of virtual functions, you've never heard of references, and you can't figure out what they are. And I would teach these courses, and by Friday, these poor people were dying. They said, we're never going to understand this. And so on Friday afternoon, I'd say, look, it's not that hard. Let's go to the whiteboard. We're going to write down what you really have to remember. So if your class has a pointer, make sure that you give it a copy constructor and an assignment operator. If you got a base class, make sure you give it a virtual destructor. Declare your data members private. Just the basic stuff. And after I had done that for a while, somebody said, you should write a book. I said, nah, I'm not going to write a book. And then somebody else said, you should write a book. And at that time, I was supposed to be working on my PhD dissertation. I said, I should write a book. So, because the book was easy and the PhD was hard. So then I wrote the book, and then things sort of picked up after that. So there was no grand scheme, it was an accident. And then to sort of cap off the story, this was 1991, and I remember my wife said to me, she said, you know, how long are you going to be able to do this C++ thing? And I said, you know, it's a programming language, it's a fad, I give it 5 years maximum. So it's doing okay so far, so there you go.
You have said quite a few nice things about C++.
Mm-hmm.
Can you say something nasty about C++? Maybe about security?
I suppose I could. You know, that sort of falls, I mean, when it comes to security, this falls into the realm of trust the programmer. It's got pointers, you can do anything you want, it's not checked. You know, that cuts both ways. If I were going to criticize C++, that is not what I would criticize. I think that's part of the nature of being a systems programming language.
Presentation I'm asking about there are a lot of people programming in Java, and what is the reason? So I'm asking you as a student, as a physical, so is there a reason to learn Java? When I'm learning C++, I'm scared a little bit because this language is complicated and Java.
Okay. I'm not a Java programmer either. Having said that, I will say that one of the things about Java and some other managed languages is they have these giant selections of libraries. So if you want to be able to do any kind of reasonably complicated task, probably somebody has done it before. And that means you often have a task of tracking down the appropriate library and then using the library. I think that's a really useful skill. I think the skill of saying, I don't want to write this from scratch myself, which is very much a C++ way of thinking. But instead, I'm going to find some existing library, and I'm going to try to combine it with some other libraries to get the application up and running in a reasonable period of time. I think that's a really useful skill. So I think that would be a reasonable reason why you might learn Java. I think also that it's useful to have used a managed programming language, which has garbage collection and pointers that can move around underneath the hood and doesn't even tell you you've got pointers. I mean, it's an interesting experience. Having said that, and bearing in mind that I don't know Java, again, my friend Andrei Alexandrescu, one of his jobs is to go and recruit people to try and see if they have what it takes to program at Facebook, which is a very demanding environment. And when he goes and he interviews students especially, he tells me that one of his standard interview questions is he says, what I want you to do is just, he goes, any programming language you want, I don't care. What I want you to do is show me how to implement a doubly linked list, even a singly linked list. And what he told me, so this is secondhand, but what he told me was the Java people have absolutely no idea how to approach that task. He goes, I'm just looking for someone to say something about a link and a node and a next pointer. And the Java people in many cases would be like, well, you know, there's a standard list class in the library. You go, well, right, but how would you implement it? So the danger of focusing too much on Java, I think, is it keeps things at such a high level that you can avoid learning about some of the lower level stuff. So if you choose to learn Java, I think it has some advantages, but just don't get stuck in Java.
In Java, we have a lot of boilerplate code, but Scala
that you can sacrifice. Good luck.
Okay.
Yo, there's a floating naked.
Okay. It's funny you mentioned Scala. I went to one talk on Scala. I'm pretty sure it was Scala.
I said something
went to
about
so I know from 3 hours of lectures on
talking
Scala.
about how we have to find
And
you
what
a
I remember
husband
about
that
Scala
will
was so,
fuck
and
you
remember, I don't know
work,
Java.
And then like,
So I'm sitting in a talk on the would-be successor to Java, and I don't know Java. And they're talking about Scala, and they're going, Scala, you can't do Java here, you can't do blah, 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 so you can do this here. And I go, I've heard that argument before.
He's going
And then they
to
go,
do.
but that leads to this kind of problem. I go, I know where this is leading. I've been there before. So my reaction to Scala was that it's recreating the C++ experience in Java. So if Scala is successful, congratulations. I have just presented your future to you in 40 minutes.
There are many features in Boost which were integrated into C++ 11 through Tier 1, and there are also many brand new features like some special frameworks like
Anybody plays PUBG Mobile?
they run their own compiler and extension to C++ language. Do you aware of any features that might be from Qt that may be incorporated in C++? The newest versions of C++, and especially something about reflection.
I am not aware of any proposals coming from the Qt community. Doesn't mean that they're not there, but I haven't heard about them. I should point out, I'm not on the standardization committee. I don't program, I don't know Java, I don't know D, I'm not on the standardization committee. I haven't heard anything about that. So that doesn't mean that they don't exist. What I do know is there are 13 study groups in the C++ Standardization Committee. A study group is sort of a subcommittee that's looking into particular issues. One of them is reflection, for example. One of them is looking into compile time reflection. So.
Okay. Hello, thank you for the talk. And it looks like the real reason why C++ did not sync is that the King of Sweden did not design it. But seriously, what is the process of language design, and how is it determined what gets into the next standard of language?
For C++, it very much is designed by committee. So I mean, there is a standardization committee, they vote on everything, and this is one of the reasons why things are less cohesive than they might be. One of the most common questions that people say is, why don't they have feature XYZ in the language? Why isn't there better reflection? Or why aren't there more libraries? And it turns out that in many cases, the answer is because nobody proposed it. So basically, what you get out of the standardization committee, what we all get out of the standardization committee is whatever this group of roughly 40 to 100 people decide that they want to work on. There is no single person who oversees the whole thing. Bjarna's on the committee. His voice has a lot of weight. He doesn't always get what he wants. Herb's voice has a lot of weight. He doesn't always get what he wants. So it's very much designed by committee. Why don't we take one more question?
Walking around at night and you see this running at you.
Did you say?
Fucking
I'm
full
only
speed.
asking out of intellectual interest.
You just see fucking some massive shark with your good glowing hair.
Because I'm bacon donut. Bacon donut is superior. Fuck off.
Look how cute
I'm
this
joking.
little thing is. It has a little mask thing.
I
Why
guess
does
I
it
would
look
say
like
it
the
isn't so
fucking
much a
flying things from
language
Doom?
feature. I think that in 2014, it is embarrassing that we have a language that has no idea that the internet exists or that we have URLs.
Well,
so I would say the two things I really miss are, number one, there really should be a library for networking and for dealing with the internet and for stuff like that. There's work being done on that, but there's nothing right now. So that, I think, is just this major gaping thing. And the second thing is, it'd be really nice to have some kind of simple graphics library, which they're also working on. One of the reasons I mention this is it used to be, I guess they still do it, when you sell your books at Amazon, Amazon has a sales rank. So of course, as an author, let's just say you are interested in your sales rank. And so I used to say that the author's hello world in any programming language was to write a program which would go to Amazon, look up your sales rank, bring it back, and plot it over time on a graph. And so in C++, you'd say, great, the first thing is I need to go to Amazon. And then if you figured that out, it was like, okay, now I need to plot it on a graph. So to me, those are the two, it's really libraries that are missing more than language features. So, I don't know what the official protocol is, but I can say my feet are tired, so why don't we stop right now? I'm going to hang around for a while if you have additional questions. Thank you for coming. Thank you.
Just listen.
Wow.
I eat rappers, cause I'm a motherfucking beat rapper. These rappers have to rap after that. You can sleep rappers, eat rappers, cause I'm a motherfucking
Is that Indian Eminem?
They're gonna be calling me copy of Eminem, that's okay. They're gonna be saying my accent is weak, that's okay.
Why is he rhyming rappers with rappers?
I'm a motherfucking rapper, bitch. I am not okay, so stop telling me do this, do that. I don't know you, who you go, that's who you. Everybody motherfucking do this now. I'm representing India, no one is doing it
बस
right
भाई
now.
बस बस
अरे मैं क्या बोलता हूँ अरे वो कैरी मिनाटी वाला सॉन्ग बजा दूं क्या?
हाँ
बजा
Mr. Indian, why is he rhyming
Yes.
rapper with rapper?
Wow.
Oh, wow, we what?
एक मिनट चलो ना बजाते हैं
Wow, wow, we what? Drop the beat! Oh no, he has a gun!
भाई वॉइस इंक्रीज कर
Lord.
That's an Indian song.
M short frog. अरे मैं क्या बोलता हूँ फिर सुन अरे ढिंचक पूजा को सॉन्ग बजा दे क्या
I wanna die, honestly. I feel like I got some disease, tuberculosis or something from these guys. I feel like I got tuberculosis from the Indian dudes.
मैंने कर दिया तो चला दे
Why are we still here?
No. Wow.
चलो कोई बचाते हैं.
Are we just gonna get absorbed?
अरे मैं क्या बोल रहा हूँ टी सीरीज के सॉन्ग बजा दूँ.
Absorbing you, bitch ass.
बजा दे भाई.
You have not absorbed. Oh, time to absorb. Human.
Oh my god.
Absorb another
series.
Hey,
we want.
absorb.
कौन सा बे? हाँ ये बजाते
Count the
हैं.
beetroot bestows upon you the blessing of the beetroot farmer.
Absorb human. Oh fuck.
I don't think they like that, bro. That's sexual
Respect
harassment.
women.
Respect women.
Respect women. Oh my god, you didn't respect her.
Kid molester. You're a bitch. Go to jail, you fuck.
बजा मैं डांस करता रहूँगा.
हाँ नाच.
Please leave me alone.
Oh, that's what happens, bro. You sexually harassed her. Wow.
How dare you?
हम लोगों के पास जाके बजाते हैं टी सीरीज का गाना.
चलो भाई कहाँ है वो?
वहाँ पे.
बजा भाई बजा गाने बजा.
Where? Fucking small one that I know. And I found it. Yeah. Oh, did you know you can, I found this today, but I never knew that you could actually VR chat without VR.
चलो भाई.
No, yeah, you can. It's just weird.
Yeah.
चलो भाई PUBG PC लाइट खेलते हैं जाके.
It's a common thing.
तुम मेरे को ना रिक्वेस्ट भेजना, ठीक है?
कौन सा नाम है?
रॉयल किंग 1-3 आर कैपिटल.
आर कैपिटल है. रॉयल किंग में आर कैपिटल है और 1 2 3.
जो मेरा नाम देखा है ना इसमें अभी, जो मेरा नाम देख रहे हो इसमें रॉयल किंग, वही सेम है, बस 1 2 3 आगे लगा देना.
Why can't I send you a friend request, bro?
I don't know.
हाँ बस यही ना.
But send me one.
ठीक है.
एग्जिट करता हूँ मैं.
Click on me and then.
वैसे भी इसमें कुछ ज़्यादा मजा नहीं है. एक मिनट इन लोग को जाके
बाद में
बोल
पता
क्या
चलेगा
जाते
ना
हैं.
इसके बारे में तो.
प्यूडीपाई के.
Oh my god.
प्यूडीपाई के बोल के आ जाते हैं लास्ट. मुझे चलो प्यूडीपाई के बोल के आ जाते हैं.
Oh, they'll probably customize it.
Hey,
डोनट.
Hey, Donut bro. Hey bro.
हेलो.
Hello there.
We want.